Good morning students. Today I am going to give you a lecture on the topics domain and Cartesian product. Now before I explain you what is a domain, you must first understand what is a set. If you see here, all these elements which are separated by comma are enclosed within parentheses. This is the opening parenthesis and this is the closing parenthesis. So these elements which are enclosed within parentheses forms a set. But what type of set is this? If you see here, the positive numbers keeps on increasing to the right hand side and the negative numbers also keeps on increasing to the left hand side. There is no n limit for the positive numbers. Also there is no n limit or end point for these negative numbers. So these types of sets are known as infinite set. And this infinite set consists of elements which are the integers. As integers represent positive numbers, negative numbers and 0, so is this set. The positive numbers are increasing towards the right hand side and the negative numbers are increasing towards the left hand side without any endpoint, and there is the number 0 in the middle. And this is an example of an infinite set. But if you see this particular set, we can determine the number of elements in this set. So how many elements are there in this set? We have the Arunachal, the first one, Assam, second one, Nagaland, third one, Manipur, fourth one, Mizoram, fifth one, Tripura, sixth one, Meghalaya, seventh one, and Sikkim, eighth one. So this particular set has 8 elements. And since we can determine the number of elements from this set, so this set is a finite set. But in this set, we can't determine the number of the elements because the elements are keeping on increasing. The elements are going on increasing towards the right hand side as well as towards the left hand side. And since we cannot determine the number of elements from this set, so this type of set is an infinite set. Now let's come to the term domain. A domain is a finite or an infinite set from which values can be chosen. Now it is possible to choose some values from this infinite set and as well as from this finite set. Now the set of all integers is an example of an infinite domain. So this domain, represented as D1, consists of the set of all integers, as integers are those numbers which comprises of positive numbers, negative numbers and 0. So is this set which comprises of positive numbers, negative numbers and 0. And since this set is infinite, that's why the domain which represents this set is an infinite domain. So D1 here is an infinite domain. Now consider the second example. The states of Northeast India is an example of a finite domain. Let's say the domain D2 represents the states of Northeast India. Now all the states of Northeast India form a set, and those are the elements of this set. The first element is Arunachal, then Assam, Nagaland, Manipur, Mizoram, Tripura, Meghalaya and Sikkim. So in total there are 8 elements in this set. Now as this set is finite, so the domain which represents this set is also a finite domain. So to sum it up, an infinite domain represents an infinite set and a finite domain represents a finite set. And remember the definition of domain. A domain is a finite or an infinite set from which values can be chosen. Let's come to the next topic, which is Cartesian product. For two domains D1 and D2, the Cartesian product, denoted by D1 cross D2, is defined as the set of all ordered pairs such that the first element of the ordered pair is a member of D1 and the second element of the ordered pair is a member of the domain D2. Now see this example. If the domain D1 consists of the elements 1 and 2 and the domain D2 consists of the elements A, B and C, then the Cartesian product, denoted as D1 cross D2, is equal to the set of all ordered pairs. So these are all the set of ordered pairs, where the first element of each ordered pair is a member of D1 and the second element of each ordered pair is a member of D2. Now the ordered pairs are formed like this. Take the first element of the domain D1 and then combine it with the first element of the domain D2. This gives the ordered pair 1A, which is represented here in the Cartesian product. Again, take the first element, which is 1 of the domain D1, and then combine it with the second element, that is B of domain D2. This gives 1B as the ordered pair, which then gets displayed in this Cartesian product. Now again, for the first element 1 of the domain D1, combine that element with the third element C of the domain D2. This again forms an ordered pair 1C, which gets displayed in the Cartesian product D1 cross D2. So by now, in the Cartesian product D1 cross D2, we have these ordered pairs 1A, 1B and 1C. Now just as how we have formed the ordered pairs from the first element of the domain D1, that is 1A, then 1B, then 1C. These are these ordered pairs in the Cartesian product. In the same way, we choose the second element, which is 2, from the domain D1 and then combine it with each of these elements of the domain D2 one by one to form ordered pairs. Then this gives the first ordered pair as 2A, which gets displayed in the Cartesian product, then 2B, which also gets displayed in the Cartesian product, and finally 2C, which also gets displayed at the end of this Cartesian product. So with the first element 1 of the domain D1, the first set of ordered pairs gets formed by combining it with the elements of D2, that is 1A, 1B and 1C, as shown here. Then with the second element 2 of the domain D1, the set of ordered pairs are formed by combining it with each of these elements in the domain D2. And the ordered pairs are 2A, 2B and 2C, which also gets displayed in the Cartesian product. So 1A, 1B, 1C and 2A, 2B, 2C are the list of ordered pairs for this Cartesian product D1 cross D2. So how many ordered pairs are in this Cartesian product D1 cross D2? If you count, there are 6 ordered pairs. 1A, 1B, 1C, then 2A, 2B and 2C, which comes to 6. Now check the second point. If there are n values in D1 and m values in D2, there will be n cross m combinations in the Cartesian product D1 cross D2. That means if there are n values in D1, so let's represent the value of n. Let's represent the value of n from this domain D1, which is what? 2. As the number of elements in this domain D1 is 2. Again, if there are m values in the domain D2, then let's represent the value of m here. For the domain D2, it has how many elements? 3 elements in this set. So the value of m will be 3. Now what will be n cross m? N cross m will be nothing but 2 cross 3 or 2 into 3. So we can say that n cross m is equal to 2 cross 3, and 2 into 3 is how much? 6. Now if you see the Cartesian product D1 cross D2, how many elements we have? We have 6 elements. So this is already been proved here. So if there are n values of D1 where n equal to 2 here, and m values in D2 where m equal to 3 here, then there will be n cross m or 2 cross 3 combinations in the Cartesian product D1 cross D2, which is nothing but 2 into 3 equal to 6. And if we count these ordered pairs, it also comes to 6. So that's all about this Cartesian product. Now consider the question in this slide. The question says, let the domain D1 consist of these elements S10, S20, S30, S40 and S50, and the domain D2 consists of the elements RAM, pen drive and DVD. Then there is a relation R which is defined by the following rule. The relation R is equal to the set of all ordered pairs D1, D2. Now watch out carefully. This D1 does not represent this domain D1. This is because this is small d1 and this is capital D1. The capital D1 denotes a domain, whereas the small d1 denotes an element of this ordered pair. Now there are 2 elements in this ordered pair. Those are D1 and D2, where the element D1 belongs to the domain capital D1. That means the first element D1 will contain the value from this domain, that is capital D1. And the second element of the ordered pair, which is D2, will contain the value of this domain, which is capital D2. But one thing you have to make sure is that D2 should be always equal to RAM. That means the second element of this ordered pair should be always equal to RAM. Now let's find out the answer. So since the relation R is defined by the following rule, we write relation R is equal to, now this rule creates the ordered pair, where the second element of the ordered pair, which is D2, should be equal to RAM. That's why in the second element of the ordered pair you always see the value RAM. and this element RAM for the second element of the ordered pair D2 comes from the domain capital D2, that is, it comes from here. And since the first element of the ordered pair, which is D1, belongs to the first domain, that is capital D1, and the elements inside these are S10, S20, S30, S40, S50, so for the first element of the ordered pair D1, we write S10, S20 here, S30 here, S40 here, and finally S50 here. Now for all these first element of the ordered pair which belongs to the domain capital D1, these elements, that is S10, S20 till S50, appears in the relation, whereas the second element of the ordered pair D2, which belongs to the domain capital D2, should always be equal to RAM. That is why the second element here is always RAM or RAM, and this puts the value of the ordered pair D1, D2 as S10 RAM, then S20 RAM, then S30 RAM, followed by S40 RAM shown here, then S50 RAM shown here. So in total, how many ordered pairs we have in this relation? If you count it, you have 1, 2, 3, 4, 5. So you have 5 ordered pairs. And that's all for today.